Hey everyone, welcome back. So you're back for more, huh? That means you're really serious about leveling up your knowledge game. And you know what? You've come to the right place. We get right to the heart of things here. No fluff, just pure insight. That's what we do on the deep dive. And today we are going to dive deep into something that's pretty academically intense,
Yeah, this one's a bit of a brain twister for sure.
but super fascinating. I mean, it's cutting edge. It's AI in finance. We're talking about Fin-R1.
Yes, Fin-R1, a new large language model built specifically for financial reasoning.
So we've got a research paper and, we've got your notes, everything, really trying to crack this open and figure out why it matters, especially, for those of us who are interested in the academic side of things. What makes this research unique? What are the big haha moments here?
Well, first things first, right? We need to appreciate just how fast AI and large language models are moving. I mean, it's incredible, the progress. But uh, when you start applying these tools to something as complex as finance, well, things get interesting from an academic perspective. There's some serious challenges.
Yeah, and the FinR1 paper doesn't shy away from those challenges. In fact, they lay out three major roadblocks. First up, the headache of fragmented financial data. Now, data fragmentation, I mean, we hear that a lot, but what's the real academic issue there? Like, what's the core problem?
Okay, so imagine this, financial data. It's everywhere. Market data, news, company filings, regulations, you name it. All these different sources, all formatted differently, updated at different times. The sheer volume is one thing, but the real academic challenge, it's that lack of a unified structure. There's no neat little box for it all.
So it's like trying to solve a puzzle where every piece is from a different puzzle.
Exactly. And for an LLM, that's a nightmare because it can lead to overlaps, gaps in knowledge, and ultimately a really shaky understanding of the financial landscape. It's hard to reason effectively when your knowledge base is, well, fragmented.
It's not just about having data, it's about having a coherent picture, right? A unified financial worldview.
Right. Now, the second big challenge, and this is a huge one academically, is the whole black box problem. The reasoning of many LLMs is opaque. You get an answer, but you don't know how the model got there.
And why is that such a big deal for finance specifically? I mean, black boxes are a problem everywhere, right?
Sure, but in finance, accountability is everything. Transparency is non-negotiable. Regulators, institutions, they need to understand why decisions are made. How can you trust a financial decision if you don't know the reasoning behind it?
Right. It's like imagine getting a loan approved, but you have no idea why.
Yeah, exactly. Or think about it from a researcher's perspective. How can you improve a model if you don't understand its thought process? How can you identify biases or errors? The black box limits our ability to trust and advance AI in finance. It's a fundamental academic concern.
So it's not just about getting the right answer, it's about knowing how you got there.
Precisely. And then there's the third hurdle. The paper calls it weak business generalization ability. Essentially, it means that general LLMs might struggle to perform consistently across different financial situations.
Okay, help me unpack that one. What are the implications for researchers?
Well, you see, the financial world is constantly changing. New products, new markets, new risks. A model that can only handle what it's been explicitly trained on is limited. It can't adapt.
So it's like you teach an LLM to analyze stock prices, and then suddenly, boom, crypto explodes onto the scene.
And that model is left scratching its head. So from an academic perspective, this highlights the need to create AI that can understand underlying financial principles, not just patterns and data. We need models that can generalize, that can apply their knowledge to new situations. And that's tough.
Yeah, it's like the difference between memorizing facts and actually understanding a concept.
Exactly. And that's where FinR1 comes in. This is what it's trying to tackle head on.
Okay, so tell me, what is FinR1? How is it different structurally from other large language models? And what makes it interesting from an academic standpoint?
Well, at its core, FinR1 is a large language model. But here's the twist. It's designed for financial reasoning, and it's relatively lightweight, only 7 billion parameters.
7 billion, that sounds massive.
It is big, sure. But compared to some of the behemoths out there, models with hundreds of billions of parameters, it's actually quite compact. And that's significant academically.
I see. So it's not about brute force throwing more data at the problem.
Right. The researchers here, they're taking a different approach. They're focusing on quality over quantity. It's about designing the model and its training process in a way that specifically targets financial reasoning. It's like building a custom race car instead of just stuffing a bigger engine in a regular car.
A very specialized tool for a very specific job. I like that analogy. So what's the big academic hypothesis here? What are the researchers trying to achieve with FinR1?
In a nutshell, I think they're trying to prove that you can achieve cutting-edge performance in a specialized field like finance without needing to build a monstrously huge model. They're aiming for accuracy, interpretability, and adaptability, all within a relatively manageable size.
So it's not just about performance, it's about efficiency and going back to what we talked about earlier, transparency.
Exactly. It's about doing more with less and doing it in the way that we can understand and trust. And to achieve this, they introduced two main innovations, Fin-R1 data and a really interesting two-stage training framework.
Let's start with the data. What is Fin-R1 data and what makes it academically interesting?
Fin-R1 data is their secret weapon. It's a high-quality data set specifically designed for financial reasoning. And here's what's really cool, academically speaking. It's built in two stages. First, they use another large language model, DeepSeek R1, to generate a bunch of reasoning examples, like chains of thought for financial scenarios. Then, they filter and refine those examples really carefully, using another LLM Q012.572b data, Instruct, as the judge to ensure the quality and accuracy of the data.
So they're using AI to create better AI training data?
Yep, pretty bad, right? It's like an LLM boot camp.
So walk me through that two-stage process. What's the thinking behind each step academically?
All right, so the first stage, data distillation, is all about tapping into the power of a general-purpose LLM to create a base set of financial reasoning examples. They use DeepSeek R1 with specific settings to encourage exploration and diversity in the generated chains of thought. They even used a standardized math prompt structure to make sure the outputs were clean and verifiable. It's all about setting the stage for high-quality data.
So it's like priming the pump with a powerful generalist AI, right?
Yeah, getting the creative juices flowing, so to speak. But then comes the really rigorous part, data filtering.
What happens in the filtering stage? What were the key academic considerations there?
Okay, so this is where they really get down to brass tacks. They use another powerful LLM, QN2.572b Instruct, but this time it's acting as a judge. They use it to check the accuracy of the answers and then to evaluate the quality of the reasoning itself. Not just whether the logic is sound, but things like consistency, diversity of thought, relevance to the task, you name it.
So it's like a panel of AI experts scrutinizing every piece of data.
And they don't let anything slide. The researchers are really focused on ensuring that only the best, most accurate, and logically sound reasoning examples make it into the final dataset. And it paid off. They achieved really high accuracy with this method, like 99.6%, and the evaluation showed that this LLM judge was highly aligned with human judgment.
That's amazing. It really shows the rigor of their approach.
Exactly. And that's not all. The diversity of the datasets they incorporated is also academically impressive. They used a bunch of authoritative sources, everything from open source datasets like FinQA and ConvFinQA to potentially some proprietary stuff. And they even included bilingual data, both English and Chinese.
So they're really trying to capture the complexity and breadth of the financial world in multiple languages, no less.
Right. It's a multifaceted approach to building a truly comprehensive financial knowledge base.
All right, so they've got this incredible data set, right? Fin-R1 data. But how do they actually train the model? They use this two-stage training framework, right? What's that all about?
Yeah, this is where the magic happens. And academically, it's quite sophisticated. First, they do fine-tuning, or SFT. Basically, they take a pre-trained LLM Q012.57b Instruct, which already has a good understanding of language, and they fine-tune it on Fin-R1 data, particularly those reasoning-heavy data sets. This helps the model start to grasp the structure of financial reasoning.
So it's like giving the model a solid foundation in financial logic.
Right? But then they take it a step further with reinforcement learning, or RL. Specifically, they use a technique called Group Relative Policy Optimization, or GRPO. It's a way of training the model to improve its performance based on a reward signal by comparing its outputs within a group. It allows the model to learn in a more nuanced and context-aware way.
I see. So they're pushing the model to go beyond just mimicking the training data and start to develop its own reasoning abilities.
Exactly. And they use a really interesting dual reward mechanism. On the one hand, they reward the model for following a specific format for its reasoning, using these think and answer tags. This ensures that the model's thought process is transparent and interpretable, tackling that black box problem head on.
Oh, so they're baking in interpretability right into the training process. That's really clever.
And on the other hand, they also reward the model for getting the right answer, obviously. They use another LLM, QN 2.5-max, to act as a judge for the final output. So the model is constantly being pushed to improve both the clarity of its reasoning and the accuracy of its results.
It's like a two-pronged approach. Accuracy and transparency going hand in hand. That's a really elegant solution. So all this fancy training, all this data, all this effort, did it pay off? What did the results show?
Oh, it definitely paid off. And the results are really exciting academically speaking. Fin-R1 scored an average of 75.2 on a multitask financial benchmark, putting it in second place overall. And keep in mind, this is a 7 billion parameter model. It actually outperformed much larger models, including the 70 billion parameter DeepSeek R1 Distilled Llama, by a significant margin.
Wow, that's impressive. So bigger isn't always better.
It seems that way, at least in this domain, and it gets even better. Fin-R1 achieved state-of-the-art scores on some key financial reasoning benchmarks like ConvFinQA and FinQA. It even outperformed DeepSeek R1 in these areas, which is really saying something.
So it's really good at the specific tasks it was designed for.
Yeah, which is exactly what you'd hope for. But here's another cool thing. Fin-R1 also showed significant performance improvements on benchmarks beyond its primary training data. Datasets like Ant Finance, TFNS, and Finance Instruct 500K.
So it's not just a one-trick pony, it's showing some real generalizability.
Right, and that's crucial for real-world applications. It suggests that the model has learned something fundamental about financial reasoning, not just memorized patterns in specific datasets. And academically, this kind of cross-tax generalization is really valuable.
So we've got this powerful, interpretable, and adaptable model. What are the implications for real-world applications? Where could FinR1 be used? And what are the interesting research questions that arise from it?
Oh, the possibilities are really exciting. The paper mentioned potential applications in areas like financial compliance, robo-advisory, risk management. You could imagine FinR1 being used to analyze financial statements, detect fraud, or even provide personalized financial advice.
So real-world impact that goes beyond academic research.
Absolutely. But there's also a lot more research to be done. For example, how do we best integrate models like FinR1 into existing financial systems? Can we develop multimodal capabilities so it can analyze visual data like charts and graphs? How does the model perform in real-time market situations?
Yeah, there's so much potential here. It's like opening a new door in AI research.
And speaking of opening doors, the authors of the paper were very upfront about the limitations of their work.
Oh yeah, they talked about the limitations of the training data, the single modality architecture, the closed scenario focus of the evaluation. What are the academic takeaways from these
Well,
limitations?
first and foremost, it shows their commitment to academic rigor. They're not overselling their results. They're acknowledging the boundaries of their work. But more importantly, it provides a roadmap for future research. It highlights the areas where FinR1 can be improved and expanded upon.
So it's not the end of the story, it's just the beginning.
Exactly, and it's a really exciting beginning.
Okay, so let's bring this all together for our listener. What's the big takeaway here? Why should someone who's interested in the academic side of AI care about FinR1?
Because it represents a significant step forward in applying LLMs to specialized domains like finance. It shows that we can achieve state-of-the-art results with a focus on quality data, targeted training methods, and a smaller, more interpretable model architecture.
It challenges the assumption that bigger is always better.
Right. And it highlights the importance of understanding the unique challenges and requirements of specific domains.
It's a real aha moment, but it also raises some big questions for the future of AI. Like, if we can achieve such great results in finance with a relatively small model, what does that mean for other specialized fields? Could we see a shift towards more knowledge-driven approaches, moving away from the relentless pursuit of ever larger models?
That's the million-dollar question, isn't it? And it's one that researchers will be grappling with for years to come.
It's a fascinating thought. So, for anyone out there who's been bitten by the FinR1 bug, we highly recommend checking out the original research paper, FinR1, a large language model for financial reasoning through reinforcement learning. It's a deep dive in itself, but well worth the effort.
And remember, staying informed about these kinds of cutting-edge developments is crucial for understanding the trajectory of AI and its impact on all aspects of our lives.
Couldn't have said it better myself. Thanks for taking this academic journey with us. Until next time, keep diving deep, everyone.